approach and retreat monitoring.
I'll be Black Charlie.
Dragon SpaceX on Big Loop. Expect reconfiguration of the C2V2 return link shortly.
Copy.
All right, so we had confirmation the crew was able to send that hold. They're at right about 203 meters away from the space station right now, it looks like.
Right now just flying in formation right in front of the space station, which is really cool.
Again, we should be getting the video views from the station itself back in just about 2 minutes from now. But yeah, Dragon holding just about 200, a little over 200 meters directly out in front. They're going to take a few.
And hopefully when we get that high data rate communication back, we'll also get some views into the cabin behind Bob and Doug. We got a few cool views of that earlier as they were getting closer and closer to station. So if you're just joining us.
Station Houston on the Big Loop for Chris. Dragon's now transmitting docking camera video. We want to confirm that video and data is updating in the Dragon 2 docking monitor.
Work. Confirm.
Copy, confirm, thanks.
In front of the space station. The astronauts aboard, Bob Behnken and Doug Hurley, have commanded a manual hold. That's to perform a manual piloting test. There is a very nice shot of the Dragon vehicle from cameras aboard the space station. You just saw one of the Draco thrusters there firing. Just to keep it in that hold attitude, flying right in front of the station.
Yeah, we have two cameras on the very forward port of Node 2, so right where Dragon's going to be headed, the completion of this manual piloting test.
Dragon SpaceX on Big Loop. C2V2 link reconfiguration complete. The soft capture ring extension is also complete.
Dragon copies on the Big Loop. Good ring extension and C2V2 reconfig.
So those comms on the Big Loop, the core, the crew operations and resources engineer here at SpaceX letting the crew know that We have a good TDRS link again, good C2V2 link again. It's common communications for visiting vehicles. And we actually heard a little bit earlier as well, comms to Chris Cassidy to monitor this manual piloting test.
Dragon SpaceX on Big Loop, you are go to execute the proximity manual flight test per procedure 4.041, and I have the target fuel levels when you are ready to copy.
Your go for 4.041, and we're ready to copy the fuel constraint.
Your 1/3 fuel usage will be 60.9, 2/3 58.9, and terminate 57.9.
We copy 60.9, 58.9, and 57.9.
All right, so they're going to start maneuvering Dragon again, making some translational maneuvers. We did get some insight that it looks like they're a little bit to the left of the docking axis right now, and so we should expect them to move directly into the center line as one of their first maneuver. That's going to be their very first maneuver, and then they have a strict list of choreographed steps just to test out moving on the other axes. And we heard the core Anna Menon calling up the expected fuel usage inside Dragon. They're going to be keeping a close eye on that just to make sure they're not overusing the propellant in this flight test, making sure we still have good margins for all of the approach maneuvers, and then obviously for everything at the end of the mission itself.
Yeah, and the thrusters that we're using here.
Dragon on the Big Loop, we are commencing the docking axis capture.
We are following along with you.
So the thrusters that we expect to see firing here would be on the service section or on the trunk. And you'll see some plumes coming out from the shot on your screen.
Figure out कर लिए कितने कितने हैं ना तक लाइट कोई लाइट ना है
The first part of this maneuver is just to really line them up perfectly with that docking axis. So they were already several meters off once this hold occurred, and so they're making very low impulse commands being sent to those Draco thrusters. Again, as Shiva was saying, there's the 12 around the lower part of the Dragon capsule that they're going to be using, and we're seeing small bursts now.
Yeah, and they actually have a couple of precision modes where they can put in sort of coarse and fine inputs into the vehicle. That's all stuff that they can control off of those touchscreen displays to get the right amount of impulsive thrust into the vehicle. If you're trying to get a little bit oriented to how the vehicle is positioned, that's the nose cone on the top of your screen. So Bob and Doug would be sitting
and SpaceX Dragon. We've completed the docking axis capture maneuver. We're going to move on to the YZ translation.
Copy, we're with you.
All right, sounds like they've got themselves lined up exactly on the docking axis, so directly in front of that international docking adapter on node 2. Now they're going to begin some lateral and axial maneuvers. So again, just putting Dragon now off the docking axis, and to just continue these translational maneuvers. So at this point, we should see them head up to the right and up from this view, as they're just making very small adjustments in the Dragon's positioning in front of the space station right now.
And here comes the translation.
We copy.
Yeah, in the data, it looks like we're seeing the 6 thrusters essentially on the bottom of the spacecraft right now from this view, lighting up. So it's going to begin to move them straight up. And it's difficult to tell, but there is a very slow drift upward right now.
Yeah, it looks like they're going about 0.1 meters a second, if I'm looking at this data correctly. So very slow and steady. And they will probably do a quick correction to stop that upward movement. It's a little surreal seeing Dragon so close to the space station. Less than 18 hours ago, I was on the pad at Launch Complex 39A. Now it's so close to its destination.
Yeah, being piloted by humans for the second time already in this mission.
Man, I would just be too excited. I don't know how Bob and Doug keep this so professional.
It's that test pilot mentality.
Yeah, they both have thousands of hours in aircraft. Both test pilots?
Yeah, both came from military test pilot backgrounds. Bob Bank in the Air Force. Doug Hurley, a Marine Corps aviator.
And then I believe Naval Test Pilot School, so. They both have thousands of hours in a little bit overexposed there, but you can still see the thrusters firing.
Yeah, our Kronos working to do that deliberately for us so we can see those thruster plumes from this camera view. We're at a normal exposure, so not able to see those jets into the darkness of space. But when we just a little bit, you're able to see those thruster plumes coming out of the Dragon spacecraft.
Yeah, it's amazing how the plume has to catch the light just the right way for us to even see that it's happening outside of data. Yeah, and looking at the data now, it looks like we have zeroed out that radial velocity delta. So Bob and Doug cleared out that small translation test that they did. We may get a radio call down here that they've completed the Y direction testing. Now, I know we've mentioned this a few times, but it looks like the spacecraft are totally still right now, and that's partially true. They're still relative to each other. But right now, both the space station and Dragon are going around the world, what is it, about once every 90-ish minutes?
Yep.
Or less?
Once every 90 minutes, seeing 16 sunrises and sunsets every single day. And while our view right now,
We've completed the Z translation, moving on to the Y.
We copy, we're with you.
A copy. So I was a little bit mistaken. They just finished up the Z direction, doing the Y next.
Dragon, SpaceX on Big Loop, you have used approximately 1/3 of your prop test budget.
And Dragon copies 1/3 of the prop test budget.
So the Corps letting the crew know how much prop they've worked through. Still have 2/3 of their budget left to do test maneuvers. And of course, any bit of propellant that they're using is just a little bit less margin if they needed to use it for something else. But a good way to exercise the system, see that manual piloting works as intended, and I'm sure for them to have a chance to provide some feedback on how manual piloting actually felt in space and how the control felt.
yeah, a big part of their job for this mission is really to not only put the vehicle through its paces, but to take a lot of detailed notes and mental notes that they're going to be passing along to any future crew members flying on board Crew Dragon. As we've talked about, the simulators have been a pretty good guide for how the actual manual goes, but things like the ascent up to orbit were quite a bit different from what they expected. And so they're just taking all of that in, internalizing it. Big part of their job once they come home is to pass that along to all of our upcoming crews, one of which is targeted to launch just about a month after that Crew 1 outfit of 3 NASA astronauts, Victor Glover, Mike Hopkins, and Shannon Walker, and a Japanese astronaut, Soichi Noguchi. We'll be aiming to do that flight a little bit later this year. So going through the paces right now, looking at our data, I think I made the U did, where I assumed them going up would be the Y-axis. It looks like that was actually their Z-axis, and the Y now them moving to the right, seeing some small shifts. They're continuing to use up a little bit of their prop budget. We heard they're already a little past 1/3.
Yeah, it's actually something interesting about both aircraft and rockets. When you consider the coordinate system, what we refer to as the x-axis is usually the one that goes through the nose. So in the case of Falcon 9 and Dragon sitting on top of each other, the x-axis would have been pointing through the nose cone going up. It can be a little bit counterintuitive. And actually in aircraft, the z-axis usually points down, depending on whether you use European or American coordinate systems and the type of aircraft you're working on. But in space station and Dragon to be on the same coordinate system as they do this eventually as they step into the approach maneuvers here towards waypoint 2. Dragon will be using its relative navigation sensors, again, for relative position to the station, to make sure that it's on the approach, within the bounds of the approach corridor going towards the station when we get to that after this manual piloting test.
We should be getting to that shortly. This manual piloting test was slated to last about 25 minutes. And as we have been running ahead of schedule today, Dragon's maneuvers, we could be looking at a docking only. So once they're done with this manual flight test, they'll turn control back over to Dragon's flight computers, and they'll resume their approach, which had actually already started before the crew issued a hold command to the vehicle. And then they'll press in to arrive at waypoint number 2, at which point the teams will do a final go for docking. They'll depart that 20-meter hold point, and it should be just about 5 minutes following that departure until we get contact and captured.
Yeah, and the crew right now are seated in Dragon in the pilot and commander's seat. Both of them are suited for what are relatively dynamic maneuvers, and they'll continue to be suited until we have confirmation of good capture on the space station. Just interfacing with the touchscreen displays, testing out manual piloting. Hopefully secretly to be piloting a spacecraft.
I mean, before they had launched, Bob Behnken had referred to this mission as Astronaut's dream, getting to launch in a new spacecraft, putting it through its paces. With those test pilot backgrounds, testing out a new spacecraft has to be as good as it gets. But they're still stepping through this manual piloting. We should have just a few more minutes until they're done with this Y-axis translation. And then they'll be able to turn command back over to Dragon, which will return itself to the docking axis and then begin that approach into waypoint 2.
Yeah, and as a look ahead, so when we do transition into that approach, Dragon will go towards waypoint 2, which is just 20 meters away from the forward international docking adapter on node 2. And that'll give the ground team some time, both in Houston and at here in Hawthorne, to do a go-no-go poll, make sure it looks healthy. Make sure that everyone on board the space station and of course on board Dragon.
SpaceX Dragon, we come to translation maneuvers. We're going to pick up with the closure maneuver.
We copy. We're following along with you.
Sounds like they're done with their translations. They're going to start moving it back to the docking axis, put us right back on the center line, zoom that approach into station.